Hello and welcome to the first session of CCE Saturdays. My name is Prasanjit Singh and today I'll talk about scaling your cloud architecture from 0 to a million users. So we'll look into how to scale up a basic cloud architecture that will serve a million plus users. So let's get started. Alright, a little bit about me. I do a lot of things actually. I work as the director of Cloud and DevOps at Starsplay. We are a video streaming service in the Middle East. Apart from that, I also teach about containers, and I'm the subject matter expert at Coursera. So I have a few courses about cloud, DevOps and containers at Coursera. And apart from that, I love to build things, and I love to be part of tech communities. I speak at various sessions as well. Recently I spoke at the RedisConf. I'm speaking at KubeCon this month. So do a lot of things around technology, as well as I run a YouTube channel called Binpipe. You can subscribe to that and check out. And I try to create content so that because I believe in the teaching is twice learning. So I believe in learning and sharing knowledge and knowing from others as well. Alright, so that's about me. So what am I going to talk about today? Well, I'm going to talk about the basics of the cloud, because this session is meant for absolute beginners. So we'll talk how the cloud works and how you start scaling in cloud. So if you just know bits and pieces about what a cloud is, so I can like this session will help you understand how to scale up your cloud architecture or application to serve up more than a million users. Okay, so we'll discuss about how the cloud works, the different jargons related to cloud, and what is scaling, how we scale up as the user base grows, and so on. So it's going to be interesting. And before we move on to it, I'll also explain some cloud related jargon so that next time you start listening to them, you find it easier to decipher. Well, scaling an on-premise infrastructure is hard. You need to plan for your peak capacity, wait for equipment to arrive, configure the hardware and software, and hope that everything is right and everything runs well for the first time. You heard that deploying in the cloud can address these headaches. So either you decided to do it on your on-premise, or you decided to give a public cloud a try. Well, if you give public cloud a try, as an engineer, you'll be assigned to set up this cloud infrastructure properly so that you can scale up to a million plus users. Well, if you're assigned to do such a task, you might be wondering if there are any best practices or guidelines when it comes to scaling on the public cloud. So this session will help you understand that, like how scaling works and what are the essential things you should know when you're in scaling up. But before we get to that, certain level of studying cloud jargons is necessary. So I'll start by describing them. Well, as you know, public clouds are nothing but physical machines set up in various data centers around the world. So a cloud is nothing but all these interconnected set of machines which you can get on demand, like you pay for it and you get to use the system. Well, now starting from a high level view of these public cloud infrastructures, the first thing you will notice is something called regions. Regions are physical geographical locations where a public cloud has clusters of data centers. So regions are obviously located all around the world, and the customers choose regions based on the proximity to their target customers, data regulatory requirements, expansion strategy, cost, service availability, and so on. In addition, public clouds provide connectivity between regions. They provide failover and also provide tools to relocate or migrate your apps from one region to other if you need that. So that is what is about regions. Now comes something else that's called AZ, or availability zones. So each region again will contain 2 or more availability zones, or AZs, and these are nothing but independent clusters of data centers designed to be insulated from failures. So AZs use their independent power grids. They sit on different fault lines and provide single-digit millisecond connectivity to other AZs in the same region. So you may they allow you to make your application highly available. Now, what does the application on the cloud look like? Let's understand that a bit, and then we'll move on with other cloud jargon again before we go on discussing how we scale our users. So the applications look something like this. Uh, you have your end users or clients who are connected to the internet from their client devices, say mobile apps, or through web portals, browsers, and so on. And through the internet, they connect to a load balancer, and the load balancer forwards the traffic back into your servers. Now, these servers can be scaled up or scaled down based on the load that comes in. By load, I mean the traffic or the usage. All right, so this is how a basic infrastructure, basic application looks like. Like, you have lots of end users accessing your application that traverses through a load balancer, and you have a scaling strategy. Well, this is how a minimal scaling works. But there are many layers to it. We'll come into that in a while. All right, so coming back to the concept of regions and AZs, well, here you can see on the left-hand side, we have, say, a region, and within it we have multiple availability zones. And as I said, all the AZs are fault tolerant. Like if AZ1 fails, AZ2 and 3 would be not necessarily failing. They would be still up and running. Now here you also see, while architecting high availability, your application might not be critical when you first get started on the public cloud, and eventually want to deploy your application over multiple availability zones so that it can withstand various types of failures. All right, so in the right side you're seeing a block diagram. Now this is something that is a blueprint of a public cloud service, like how the public cloud offerings are differentiated into various layers. So a public cloud provides infrastructure, and these infrastructure could be network services, compute services, and storage services, basically these three. And then public clouds provide data services, they provide application services, and they provide deployment, administration, security, governance features. So combining all these basics or pillars, we can build our architecture. So when we are moving from 0 to 10,000 users, what are the different services that we would be looking at in order to get this built? Now, how do we build a scalable architecture that can serve up to 10,000 users? Well, if you just want to get your hands dirty, you could start deploying a simple application on a single box. Okay, so say your website is a LAMP stack, say a WordPress stack, a blog, or something a little bit more complex, a CMS-based system like Drupal, or a framework, or a CRM, open source CRM like vTiger or Sugar CRM. Say you have such an application and you want to deploy it, and you would want anywhere between 0 to 10,000 users. So you can just start to host it on a single virtual machine instance. So you spin up a virtual machine, you install a web server, application server, and a database on the same instance, and cloud providers make it very simple for you to create virtual machines, and you already have baked images for different operating systems, and some of them have pre-built application servers, databases in them, so you can just spin up those images and get your virtual machine ready, up and running. Next, you would want to deploy this virtual machine somewhere inside a secure virtual network, such as a public subnet inside a VPC. To host DNS records for your server, you could use a DNS service provided by the cloud provider. Well, I came across a term called VPC. For those who are not initiated into it, VPC stands for Virtual Private Cluster, and lets you provision a logically isolated section in the cloud where you can launch the resources in a virtual network that you define, and you have complete control over the IP address range, subnets, and routing rules. Now, what is a VPC subnet? A VPC subnet is a slice of overall VPC IP address range tied to a AZ. Virtual machines deployed into a public subnet can randomly have assigned public IPs and are visible from other internet hosts. To make a subnet public, you need to create a routing rule for the subnet and direct inbound traffic to go out of your subnet through an internet gateway. So that way your networking works here and you have your DNS rules set up. Well, this original architecture of running everything on one physical node is good enough, but there are certain challenges. When the traffic ramps up, now you start wondering how you can scale. A quick solution is to vertically scale by spinning up a bigger virtual machine. Like say if you have 2 gigs of memory and say you have 40 gigs of hard disk on which your application is running and you're running out of space or running out of memory, then you can just have a bigger box and still keep running your show. Well, but that is not the solution. Like this is called vertical scaling, but this is not a very good scalable solution for traffics that continuously keep on growing. You would be ending up spending more if you practice vertical scaling, and it also becomes a single point of failure if you just have a very big instance running and everything is on that same box. So to address the vertical scaling challenge, it's recommended you start with decoupling your application tiers. Now, application tiers are likely to have different resource needs that might grow at different rates. By separating the tiers, you can compose each tier using most appropriate instance type based on different resource needs. When we apply the concept of decoupling to the original architecture, then the new architecture will look something like this. Well, now what we have done and how is this different from the previous one? Let me go back to the previous one once more. Well, here you can see there is just one instance, EC2 instance, meaning the virtual machine instance. This is a diagram taken from AWS use case, so EC2. Well, the virtual machine instance is a single instance which is inside a public subnet, inside a AZ, which is in a region in the cloud, and you have your website running on the EC2 instance, and you have Route 53, that is the DNS, pointed to your website and through an internet gateway. So your users are routed through the internet gateway to your EC2 instance where Apache is serving a website and you have your database running on the same server. So that was something which served you 0 to about 10,000, but when you're growing, I mean even before you reach 10,000, depending upon what kind of application it is, you can face challenges. So vertical scaling is not the solution. In that case, what we do is we have this something called horizontal scaling, but before we can do that, we have to decouple our apps. So to do that, we are now splitting our instance into 2 instances or virtual machines. So on one of them, it would be running your applications or the web server. On the other, it would be running your database. Everything else remains the same. So here, once you have decoupled, you can see where you have the load, whether database is the bottleneck or the application. If application is the bottleneck, you can scale that up if database is the bottleneck, there is no very not a good solution here in this architecture. We'll come to that in a while. All right, so you can spend some time with this diagram and try to understand if everything is clear. And now, to design your application so that it can function in a distributed fashion, for example, you should be able to handle a request using any web server and produce the same user experience. Your application state should be stored independently so that subsequent requests do not need to be handled by the same server. Now here, this is another challenge. Now, let me give you an example. Say you have split your application and database, and you see that whenever there is higher load and you scale up the application servers or the web servers, you are able to serve all your customers perfectly well. But there is a challenge, like what happens, the traffic comes in through a load balancer, and say you have multiple virtual machines running your application servers, your Apache servers. So say the traffic comes into the load balancer, the first user goes to server A, second user goes to server B, third user goes to server C, and there is a round robin algorithm in place in the load balancer, so it is rotating the traffic one after another. And say the user logged in and his session information was created on server A, and the next request from the user lands up in server C where the session information is not there. So the user is logged out of the website. So this is not a good solution. So how do we handle that? So to do that, we have to make sure that the servers are stateless. And once that is done, that can be done in numerous ways, like storing the session on the database. Not a very good practice, but it works. Or you can have a cache, like something like Redis, something which is a common cache accessible from all the application servers, and session is stored there. But there is a challenge too, like that becomes a single point of failure. But that is another problem that we'll deal with while we are discussing. So for now, we know that we can scale it by splitting or decoupling, and we can scale up the application server separately and database server separately, and we somehow take care of our session or the state, and we make our instances stateless. So that way it is horizontally scaled, and everything works fine. Load balance traffic, and everything goes good. But even this cannot sustain traffic after a certain limit. Mostly seen 10,000, 15,000 users can be sustained with this kind of an architecture. Now, if you're growing, then it becomes difficult to sustain more customers. So what do we do next when we have more concurrent users on our website, and we see that this architecture with split database and different application stack, or a basic three-tier architecture starts to fail? So what do we do next? Well, this is also the same diagram, like when we scale up and how it looks. So it's basically the same thing. All right, when we scale beyond 10,000 and move on to say 500,000, how does it work there? Let's quickly get into that part. Well, in the previous architecture, I told you, like, one of our bottlenecks is the database. Now this database doesn't grow. You can also only scale it vertically, not horizontally. But yeah, the application stack, if made stateless, can be horizontally scaled. But database becomes a bottleneck as soon as you cross your 10,000 users on an average. So here, if you're on the cloud, the best thing you would do now at this stage would be to use a managed database service, so that you do not have to do the hard work of setting up your master replication, where you are balancing your load, or you are splitting your reads and writes, so that the read is done from a different database and write is done to a different database, and you have a MySQL replication going on, master slave, or circular replication, master. So you do not have to deal with that. So that's why it's very convenient to use a managed database at this point. All public clouds offer managed database services. You can use that. And for the session that I was saying, you can use uh, something like Redis. Even managed versions of Redis are available in public cloud, or you can use NoSQL databases, managed versions, because we are planning to build a cloud native app. So we are not going to uh, just do a lifting and shifting way of working, where we just create virtual machines and install everything on virtual machines. So we, whenever there are managed services available, we use them, and when it's not there, we obviously do it on our virtual machines. Well, so another decision you make is where to use SQL and where to use NoSQL. Because at this stage, when you're trying to scale from 10,000 to 500,000, your application needs to be tweaked in a way you can deal with this kind of a customer base. So just having a MySQL or relational database service would not help. So here you might need NoSQL databases. Uh, now, what is SQL and NoSQL? Just in case you do not have a knowledge about it. Well, when you do not know, like, whether to use SQL or NoSQL, the best option, or the best starting point, is to use a SQL or relational database. So, because it is a well-established technology, and you have lots of existing code examples and clear patterns of scalability, so you can use that. But if you have highly non-relational data, then NoSQL is a better bet. And if you do not need to store relationships between data objects to extract information, storing data in NoSQL using a key value format provides you with input and output data quickly. And you have when you have massive amounts of data in the terabyte range, then NoSQL allows you to scale horizontally, because it stores data in the key value format and can be easily sharded. By sharding, I mean partitioning the databases. NoSQL data architecture can also maintain, high throughput even for large data sets, uh, and you can rapidly ingest lots of data. So these are some advantages of having or using NoSQL databases. Well, coming to this diagram, you might be wondering what this is. So here, it's just a representation of how our architecture will look like. Like, we are scaling up our virtual machines, and to maintain high availability, we are scaling it over various subnets in different AZs. And you can see them in the base of this image, the master and the slave databases. They are in different availability zones, and there is a replication going on. So this is ideal way to have a highly available database that serves up to 500,000 users. Now, clouds also provide multi-AZ features where they replicate over multiple availability zones. All right, so if your user base still keeps growing, and after decoupling your application tiers, you're ready to horizontally scale, then you can start adopting this kind of an architecture. Now, this kind of an architecture at an application level needs load balancers. Now, these software-based load balancers that are provided by clouds, or some name it elastic load balancers. So these are horizontally scaled services that require zero administration from your end, and they support SSL terminations and sticky sessions. Well, what is a sticky session? Like, when the request comes in for a particular user, the request lands on a particular virtual machine or application server, and all the requests from that particular user are made sticky, so that they land up on the same application server. So that is sticky session, so that the user has this session saved on the same server, so no discrepancy on the user that the user faces. All right, and what else do we do to sustain 500,000 users is using splitting your databases, read and writes. So in this particular diagram, you can see you have your application servers in different availability zones, and they can horizontally scale, and you have your private subnets where you have your say applications running there. So you have a three-tier architecture. You have web tier on the top, multiple VMs, and then you have your application servers which are connected to the databases, again multiple uh, virtual machines, and then you have your databases which have read replicas, and uh, they have multi-AZ deployments. So all the databases are redundant and they can survive a failure. So now you might be thinking how to do that. You do not have to do that if you're on a cloud. You can use uh, the service providers database offering. So that is the ease of deploying architectures on the cloud instead of natively doing it on premise. On premise teaches you how to do things correctly, but cloud helps you do things faster, which matters more to your business because you're focusing on your business, the success of your business, rather than just learning how to do it. That can be done in your proof of concepts. All right, so how do we gain from this architecture and how does it serve up to 500,000? Number one, we did horizontal scaling of the application layer. We had multi-AZ databases. We had read replicas, so the read operations are split and write operations are split so that everything works well. And it works pretty well. But this can be decoupled even further. So how can that be done? Well, your application might have some static files or static assets. Well, you can store those assets in your block storage, but that is not very efficient. You can store them on object stores. That is economical, and you can scale it in the long term, and it's very cost effective. All right, so you use the simple storage service for this, and you use offerings like DynamoDB or MongoDB, where you store your data as flat files instead of storing them on relational database system. And you use caching systems to make it more scalable. Caching is very important, makes the website blazing fast. So that is how it can serve large numbers of customers. But how can we beef up this even further? It's possible. Now, whatever we did until this point was manual, like adding new virtual machines whenever we are anticipating more load, or adding our database replicas, and so on. So everything was manual. But clouds offer to do all this automatically for you. So how do we do that? Here, auto scaling comes in. Now, auto scaling is nothing but monitoring your services, detecting the bottleneck, setting a trigger, like what happens when that bottleneck is hit, and what is triggered, and what does that trigger do. So these factors come in. So if it is a application bottleneck and say your CPU hits a certain limit, or your concurrent requests hit a certain limit, then you trigger your auto scaling activity that adds more application servers. If there is a database bottlenecks, maybe it spins up new instances of your database, or if it is a bottleneck in your caching system, it scales up your caching capabilities and so on. So after you shift workload components to appropriate cloud services and decouple your applications, like we did in the past slides that we discussed, you can introduce auto scaling to squeeze more efficiency out of your infrastructure. In the traditional infrastructure world, where you had to provision a fixed number of servers, you're forced to stand up servers based on your peak demand. This method of server procurement forces you to do capacity planning and wastes money on unused server capacity. Well, what do you have after these tweaks? You have something that looks like this. So you have CloudFront or CDN, that is a new addition where you can store your static content, or you can, and this CDN fetches content from origin, which is object store that I spoke about, which is S3 in this diagram. And then you have DynamoDB, which is a something like a MongoDB flat file database. So here you have your assets, and then you have your regular database, your application layers, which now can be auto scaled because you have auto scaling triggers on your load balancers, and you have auto scaling groups and all that, so that they can be auto scaled. Then you have caching systems like Redis, which are offered by these cloud providers, and you have your web server layer as well. And so that is how it looks like now, auto scaled, and works pretty well. But there are again some challenges. Let's discuss that. Now, in the traditional infrastructure world, where you have to provision a fixed number of servers, you're forced to stand up servers based on your peak demand. This method of servers procurement forces you to do capacity planning and wastes money on unused server capacity. Let's take a look at this graph. So what happens, say for example, this is a CRM website which employees use. So you will see at a particular time there is a peak requests, and at the night no one is accessing the CRM, then it goes down. Or probably over the weekend no one accesses and it goes down. But the rest of the time you see a peak usage, and there is a pattern that happens every day. So whenever there is no usage and you are using a traditional infrastructure, then you keep paying for the hours when there is low usage as well. So this is not very cost effective. So peaks and lulls will be there throughout the week, and as a business owner, how do you ensure a great user experience, and how do you ensure a cost effective way of deploying this? So the answer again is auto scaling. So whenever there is a bump in traffic, your infrastructure grows, and whenever the traffic is less, the infrastructure cools down and shrinks. So that is how you save your money there. So clouds provide you that feature as well for scaling up and scaling down without issues. Well, if you look at this diagram, you will see a single application tier that uses auto scaling to automatically scale the web servers. You could have another auto scaling group for your application tiers that are in the private subnets as well. And when used in combination with elastic load balancing, the auto scaling knows to register or deregister the virtual machine instances by using health checks. So the ELB conducts health checks on the virtual machines, and if it comes up as healthy, it registers it. If it is not healthy, then it drops it from the load balancer. So that is how it works. Rest of the infrastructure remains same, like the CDN, object store, databases, etc. So this way, it can serve 500,000 plus. Like if you have auto scaling in place, managed databases, caching in place, and you have these splits of application tier, database tier, and web server tier, and you manage your static files via CDN, then it allows you to manage 500k plus. But as you're moving to 1 million, managing this big infrastructure becomes difficult. So here you will need some automation. As your environment scales, it becomes less and less efficient to manage all these workloads. So not only Your manual deployments take time, but also it makes room for human errors. And that is where you need automation, that which people say DevOps nowadays. Well, that's a different philosophy altogether. We'll talk about that in some future session here. Well, automation, how does it benefit? It provides, like, allows you to do rapid changes in a big architecture, such as the one which we are discussing, 500,000 plus customers. And it allows improved productivity, it allows repeatable deployments, it allows to reproduce environments, and you can use tools like Terraform to do that, or Ansible to deploy softwares, and so on. Well, leveraged elasticity. Now, automation allows you to shrink or expand your cloud resources. Say you use Terraform to spin up instances, and you use Terraform again to kill instances and shrink down your architecture. So all that can be done, and different automation methods are also available in public clouds. And last but not the least, you have automation testing. So automation helps you in lots of ways, and there are specialized services to do that. Every cloud has these specialized services to do all kinds of automation. And apart from that, you also have provisions to monitor your stack, because at this point, when you're crossing 500,000 customers, it is imperative you monitor your stack. So logging and monitoring options are also available with private clouds, so you should use them. So you can use something like a ELK stack and push your logs into Elasticsearch and use Kibana to visualize your logs. You can use monitoring tools and graphing tools to monitor the state of your system. Well, as you approach 1 million users, you need to be more careful. So how does it go when we reach almost 1 million users and counting, like more than 1 million? So what have we done so far? We have decoupled application tiers to prepare for uh, horizontal scaling. Um, we have used database systems that are cloud native, like managed by the cloud provider, database as a service. We have used shift components of workload and shifted them to cloud native services. For example, we put our static files outside our web servers into um, CDNs. We used object stores, we used caching systems, and so on. And we applied auto scaling so that the instances can scale up. And apart from that, we also used automations. So we have done all this so far. Now, how do we go more into this? Like, as we grow, how do we work more into perfecting this? So apart from decoupling and going through the path like we did, the answer when you are growing over 500,000 and approaching a million is using something called SOA, service-oriented architecture. So instead of just splitting your application by server roles, for example, web or application servers, you can consider splitting resources further by the service they collectively deliver. So I'm talking about microservices now. So the benefit of this is that you can scale each service independently, and your web and application tiers will have different resource requirements, and so will your different services. Now, adopting service-oriented architecture sounds great, but it's a bit challenging, with difficult to manage with limited resources, because say if you split your application into multiple smaller microservices, so you will need individual caretakers for these microservices, so you need a bigger team for that, like more developers and so on. However, it's manageable. Need to get the hang of it. And you need to have good build practices. You should use CI/CD pipelines and all that, so that the deployment becomes automated, because when you have hundreds of microservices, it's not easy to just go on and deploy things in 100 different places, even with automation. Like someone has to run that Terraform, or if someone has to manually run that Ansible to deploy, that's not something very effective. You can do the entire CI/CD process automated with test cases in between and all that. So having SOA architecture helps scale more than uh, a million plus users. And to help you achieve that, like cloud providers have all these features available nowadays. You can containerize your apps, and you can put it on orchestrators like say ECS or Kubernetes, uh, GKS, and so on. So that allows you to uh, split it into microservice and then serve a lot of traffic, million plus traffic. And there are certain more things that you should keep in mind. You should not try to invent everything or reinvent everything. For example, you want to send out alerts. So you should not be having a virtual machine and putting up a SMTP server on that, maintaining that server, and sending your mails out through that SMTP. So it doesn't work that way in the cloud, because cloud already provides you various things like sending emails, queuing, asynchronous message queuing. If you are a video streaming provider, clouds provide you transcoding mechanisms. You have monitoring tools, logging tools, like we discussed, and you can just use them right away instead of building it on your own and then using. Now let's just discuss a bit like what are the other challenges and how do you scale over 1 million. Say you're moving up to 10 million customers. So how do you do that? So some of the tips are you would be deploying across multiple availability zones. You would be using elastic load balancing between tiers. You would be using auto scaling. You would be using service-oriented architecture. You would be serving content using S3. All this we have discussed, but that's what you would continue doing. And yes, now that you are serving more than 1 million, your database would need some attention. So you can use techniques like database federation, like separating databases by function. For example, you might choose to store data for your forum, users, and products in 3 or more distinct databases. And this allows your components to scale independently. So now your database is also following an SOA strategy. So you are having each microservice with its own database, so that you can independently move that around without having to move the entire big monolith database. Then you can practice sharding or partitioning your databases if it becomes too large. And as we discussed, you can use NoSQL databases. If you have independent tables in the relational database that are NoSQL friendly, then you can do that. So that is how you scale and you serve customers more than 1 million. Hope you liked this session. This was the overall session, so it wasn't focused much on one particular architecture type, but in future sessions, based on your requirements, you can just reach out to me on our Slack channel for CCE, and we can discuss there, and I can record future sessions on particular topics that you would want me to cover. And we will also have some fantastic speakers in future sessions, so hope you enjoy watching them, and it would be a good learning experience for you and me. Thank you.